So hello student, once again welcome to your favorite channel AVM Tech Android. You can use this QR code to see the free videos. Again I am available with the chapter 2, topic 2 for the basic mechanical engineering. The chapter 2 title is property of gases. We are talking about topic 2, that is the constant volume process for basic mechanical engineering, and we are talking about chapter 2. Again, this is a QR code for the channel and the channel name is AVM Tech Android. Now, before we'll talk about this constant volume process, first we understand what do you mean by non-flow processes. So, in the non-flow processes, the same mass of gas remains inside the system throughout the process, and there is no mass entering or leaving the system boundary. Means mass cannot cross the system boundary. So you can say example is a gas trapped in the piston cylinder arrangement, or you can say air that is available in the balloon, etc. So here mass transfer is not possible, energy transfer is possible. So these processes describe how the gas behave when the pressure, temperature and volume change under different conditions. So now onwards we have to talk about different non-flow processes, that is the constant volume pressure, constant temperature process, constant pressure, constant temperature, constant volume, polytropic, adiabatic process. So all these are non-flow processes. So we start with the constant volume process, widely known as the isochoric process. Student, keep in mind that generally the derivation will not ask in the exam. The numerical will be asked. Depend upon the type of the numerical, 3 mark, 4 mark or 7 mark weightage is given to the numerical part. So the derivation may not ask, but we must understand fundamentally, then and then we can solve the numerical. So what is constant volume process? A constant volume process, which is also known as isochoric process, is a thermodynamic process that occurs at a constant volume. During this process, pressure and temperature may vary, but volume remains constant. So what you can see here is the system. This is a piston cylinder arrangement and piston is fixed. Now what happens when either heat is supplied or heat is rejected? So what happens? The P and T, pressure and temperature will vary, volume remains constant. So what you can see, V is constant, and when we plot the same thing on the PV diagram, we can see it is a straight vertical line where initial state is a 1, final state is 2. So here 1 to 2 means the heat is supplied and initial pressure was P1, now the pressure is P2. So when the heat is supplied, what you will observe, final pressure is P2, temperature is T2, but definitely V1 is equals to V2, volume remains same. So we have to find out relationship between Q, that is heat, work and internal energy as per the first law of thermodynamic. So for the constant volume process, what is the Q value, what is the W value and what is the change in internal energy, that three things we have to find out. So what is the relationship between pressure and temperature, that we have to find out first. So what we can see, as per the ideal gas law, PV equals to MRT. At constant V and R, P is proportional to T. So what we can tell is P1 upon T1 equals to P2 upon T2, and that is nothing but our Boyle's law. So at constant volume, the pressure of a given mass of a gas is directly proportional to the absolute temperature. So that is known to us. Now we have to find out work done. So we know work done, that is integration between initial volume V1 to final volume V2 with PdV. but as it is a constant volume process, change in volume is 0. So as it is a constant volume process, V1 equals to V2, so dV is 0, so W is 0. So no work is done because no change in the volume. So W part is 0. Now what is change in internal energy U? So for any thermodynamic process, internal energy delta U, that is mCV into T2 minus T1, where CV, that is specific heat at constant volume, unit is joule or kilojoule per kilogram. Since the work done is 0, all the supplied heat goes to change in internal energy. So you can say, as per the first law of thermodynamics, Q equals to delta U plus W. When W is 0, what you can see is Q equals to delta U. So all the supplied heat goes to change in internal energy. Hence, for the constant volume process, heat supplied equals to internal increase in the internal energy. If heat is rejected, there is a decrease in the internal energy. So you know what is the formula to find out heat, formula to find out internal energy, and formula to find out work done. Summary is given here for constant volume process. Volume V is constant, so there is no expression. Pressure and temperature relation, P1 upon T1 equals to P2 upon T2. Pressure is proportional to the temperature. Work done is 0 as there is no mechanical work. Volume remains constant. Change in internal energy U, that is mCV delta T, that is depend upon temperature. Q, that is heat supplied, that is equals to delta U, the entire heat change internal energy. If heat is supplied, internal energy will increase. And what is the first law equation? Q equals to delta U plus W. W is 0, so Q equals to delta U. Now we try to solve one simple numerical related to this process. This kind of numerical may be of 3 mark, 4 mark to the 7 mark. So you should prepare this kind of numerical. So in the data it is given that 1 kg of air is heated in the rigid container from 300 Kelvin to 500 Kelvin. Find the heat supplied and change in the pressure. Okay. So here rigid container is given, temperature that will vary from 300 to 500 Kelvin. CV is given 0.718 kilojoule per kilogram Kelvin. R value, that is 0.287 kilojoule per kilogram Kelvin. Initial pressure P1 is given 100 kilopascal. We have to find out change in pressure, that is we have to find out P2 also, we have to find out heat supplied also. The question may be there, find out W also, find out this Q also, and find out delta U also. If these three will ask, the weightage is of 7 mark. So what you can see in the solution is, first we have to find out heat supplied. So heat supplied Q is equals to mCV delta T. M is 1 kg, CV value is given 0.78. Delta T is change in the temperature, that is 500 minus 300. So heat supplied is 143.6 kilojoule. Pressure change, that is P2 by P1, that is equals to T2 by T1. T2 is 500 Kelvin, T1 is 300 Kelvin, P1 is 100. So we will get P2 value, that is 166.67 kilopascal. This, friends, these units are very important. Here the unit is kilojoule, here the unit is kilopascal. These units are very important. So your final answer Q is 143.6 kilojoule and pressure is 166.67 kilopascal. This kind of numerical, if the question is there to find out W, so you have to write W is 0. If you have to find out delta U, you can say delta U, that is equals to delta Q, and again that value is 143.6 kilojoule. So this kind of numerical may be of 3 mark, may be of 7 mark. So I hope you will prepare this kind of numerical by your own. And this is about the constant volume process. Again, do not forget to subscribe this channel, like this video and share this video as well as channel to your friends across the state in the different institute. Thank you very much.